And this is one of the most important concepts in linear algebra, the linear combination. So a linear combination looks like this. So you've got a vector y, and you can write that vector as a sum of other vectors, and there could be many of these. And these vectors have these scalar coefficients. So we'll call this A1, A2, A sub n. So the A's are scalar constants and the V's are vectors. So if the vector y can be written as a sum like this, then we say y is a linear combination of the vectors v1, v2, up to v sub n. So you're combining these vectors v1, v2, v3, all the way to v sub n. You're combining them together in such a combination that when you add them up together, you get the vector y. So if let's do an example here. Let's say v1 is 304. I'm just making this up. v2 is 1, 1, negative 2. And v3 is 0, 0, 7. So if I were to say, let's just make this up. Let's say 2v1 plus 3v2 minus v3. What is that? So 2v1, that would be 608. 3v2 is going to be 3, 3, negative 6. And then let's multiply the scalar of negative 1 here. Negative 1 v3 would be 0, 0, negative 7. And if I add those together, I get, let's see, 9, 3, and looks like that's negative 5. So this vector here, we'll call this y. This vector is the result of combining these three vectors together in a particular combination where we picked some scalars and we combine these together and we get this new vector. So say y is a linear combination of v1, v2, and v3. So here we have x1, x2, and we have a vector b. These are in R3. They have 3 entries. Determine whether b can be written as a linear combination of x1 and x2. So that would mean, let's say, a1 x1 plus a2 x2 is equal to b, right? So if x1 and x2 can be combined together to form b, then I need to figure out a1 and a2 that make that happen. Okay. So let's remember that when we had so let's look at this part and see what does this actually mean, right? So a1 times x1, that's going to be a1 times 1, a1 times negative 2 a1 times negative 2 and negative 5 times a1 plus this part a2 times x2, so it's going to be 2a1, sorry, a2, 5a2, and 6a2. And that is equal to b. And if we add these together, right, we get a1 plus 2a2 negative 2a1 plus 5a2 negative 5a1 plus 6a2 equals 7, 4, negative 3. And you can see here, all this is a system of equations, right? It's a1 plus 2a2 equals 7. Negative 2a1 plus 5a2 equals 4. Negative 5a1 plus 6a2 equals negative 3. So we know how to solve this system for a1 and a2. We use augmented matrix. So what are the coefficients here? 1, negative 2, negative 5. 2, 5, 6. Augmented with 7, 4, negative 3. And these columns are the coefficients of the variables a1 and a2. So I'm going to use my calculator here to save some time. I'm going to put this in to a matrix. So this is a 3 by 3. 1, 2, 7. When you enter in the matrix here, you have to enter it by row. Negative 2, 5, 4. Negative 5, 6. Negative 3. So now I'm going to use RREF on the matrix I just made, and I get this. Remember, it's augmented here. I've got this row of zeros, but every column has a leading 1 that is associated with a variable. So that means I don't have any free variables. This is one solution here. So the first row says a1 is equal to 3. The second row says a2 is equal to 2. So that's my solution. Now let's try this out and see if we actually do get b. So if I multiply x1 by 3, I get 3, negative 6, negative 15. And then if I multiply x2 by 2, I get 4, 10, and 12. And let's just see if I add those together, do I get b? And the answer is yes. So determine whether b can be written as a linear combination of x1 and x2. The answer is yes. So let's write it down here. So yes, I can write b as 3x1 plus 2x2. And that's my linear combination. So these ideas here kind of go together with our systems, right? So if I say b is equal to a1 x1 plus a2 x2 plus a sub n, x sub n, if I were to put these into a matrix where the columns of my matrix are these vectors, augmented with the b vector, these two have the same solutions. And this guy here is called a vector equation. So what it means is we have these systems that we already know how to solve with matrices, and we can use that same system to solve these vector equations. And in fact, any system that you have can be written as a vector equation. Right? You can change it around so that it's a vector equation instead of a matrix, instead of a system. But they're kind of the same. They're the same thing. Just we're just looking at it in a different way.